For centuries, it was a ghost. A shadow whispered about by sailors, a myth etched into the margins of maritime maps, a monster with arms long enough to drag ships beneath the waves. But the truth is far stranger than the legend. Because in the silent darkness nearly a kilometer beneath the surface, the creature we call the giant squid is not a raging monster at all. It is something far more unsettling. Something we misunderstood. Far below the reach of sunlight, the ocean transforms. Light fades into blue, then into black, until color itself disappears. Pressure mounts to crushing extremes. Temperatures hover just above freezing. This is the deep sea, a world where sight is nearly useless, and survival depends on senses we barely understand. And here, in this vast and silent darkness, lives the giant squid, a creature that can stretch longer than a bus. Eyes the size of dinner plates. Arms lined with rotating hooks capable of gripping prey with terrifying precision. For decades, scientists believed they understood how it hunted. They thought it was an active predator, chasing fish, lunging through the darkness with speed and power. But that assumption was wrong. The giant squid's body tells a different story. Unlike fast predators like tuna or sharks, its muscles are surprisingly soft. The mantle, the main body, is not built for sustained speed. This is not the anatomy of a relentless chaser. It is the anatomy of something patient, something that waits. Its most striking feature is not its length. It is its eyes. Among the largest in the animal kingdom, each eye can measure up to 27 centimeters across. Larger than a human head. At first, scientists assumed these enormous eyes were designed to spot prey in the darkness. But that explanation never quite fit. Because in the deep sea, prey is scarce. Visibility is limited. And large eyes are energetically expensive to maintain. So why evolve such massive vision? The answer began to emerge from an unexpected direction. Not from observing the squid itself, but from studying its enemies. Because the giant squid is not the apex predator of the deep. It is also prey. Far above it, diving from the surface into the abyss, is its greatest adversary. The sperm whale. A titan of the ocean, capable of descending thousands of meters in a single breath. Equipped with echolocation powerful enough to map the darkness with sound. When a sperm whale hunts, it becomes a living sonar weapon. And the giant squid has no way to hear it coming. Or so we thought. In the absence of sound-based detection, vision becomes critical. But not for spotting prey. For detecting something else entirely. Disturbance. Movement. The faint shimmer of bioluminescent organisms reacting to something massive passing through the water. In the deep sea, many small creatures glow. Tiny flashes of blue light ripple through the darkness whenever something disturbs them. A passing predator, a drifting current, or something much larger. Something like a whale. Recent scientific models suggest that the giant squid's enormous eyes are not designed to see individual objects clearly. They are designed to detect patterns of light. Specifically, the cascading glow triggered when a massive predator moves nearby. In other words, the giant squid doesn't just see in the dark. It watches the darkness itself react. This changes everything. Because it means the giant squid is not primarily a hunter of speed. It is a creature of anticipation. A master of stillness. And this leads to a deeper question. If it isn't actively chasing prey, then how does it catch anything at all? The answer lies in its arms. 8 shorter limbs, and 2 extraordinary feeding tentacles. These tentacles can extend with incredible speed, shooting forward like biological harpoons. At their tips are specialized clubs lined with suckers and serrated hooks. Unlike the smooth suckers of most squids, these hooks can rotate, digging into flesh and holding fast. But here's the crucial detail. These tentacles are not designed for prolonged struggle. They are designed for sudden, precise strikes. Ambush. Imagine drifting through the deep sea. A fish, navigating by faint glimmers of light. There is no sound, no warning, and then, from the darkness, 2 tentacles explode forward. In a fraction of a second, the prey is seized, pulled inward, and consumed. No chase. No pursuit. Just a single, decisive moment. This is not the behavior of an active predator. It is the behavior of something lying in wait. Something that allows the ocean to bring food to it. But how does the giant squid position itself in such a vast, three-dimensional environment? How does it know where to wait? The answer may lie in one of the most mysterious features of its biology. Neutral buoyancy. Unlike many fast-swimming animals, the giant squid appears to hover effortlessly in the water column. Its body is slightly less dense than the surrounding seawater, allowing it to remain suspended with minimal effort. This means it can drift, almost motionless, waiting, watching, and in that stillness, it becomes nearly invisible. Because in the deep sea, movement is everything. Anything that moves stands out. Anything that doesn't disappears. The giant squid may spend long periods simply existing. Arms extended, tentacles poised, eyes scanning for the faintest disturbance in the darkness. Not chasing, not searching, just waiting for the right moment. This strategy is known as sit-and-wait predation. It's used by creatures like ambush sharks and certain deep-sea fish. But in the giant squid, it reaches an entirely different scale. Because here, the ambush is not hidden among rocks or coral. It is hidden in open water, in the vast emptiness of the deep ocean. And yet, this strategy raises another question. If the giant squid is so still, so passive, why does it have such powerful tentacles? Why such elaborate hooks? Why such precision? Because in the deep sea, opportunities are rare. You don't get many chances. When prey appears, you must succeed. There is no room for error. No second attempt. The strike must be perfect. And so, evolution has shaped the giant squid into something paradoxical. A creature of stillness, equipped for explosive action. A predator that does not hunt in the traditional sense, yet is perfectly adapted to capture prey. But the story doesn't end there. Because even this new understanding may be incomplete. For decades, the giant squid remained almost entirely unseen in its natural habitat. Most specimens were discovered dead, washed ashore, or found in the stomachs of whales. It wasn't until the early 21st century that scientists finally captured the first images of a live giant squid in the deep ocean. And what they observed raised even more questions. The squid did not behave like a passive drifter. It showed signs of curiosity, caution, even intelligence. When presented with baited cameras, it did not immediately attack. It approached slowly, tentatively, as if assessing the situation, as if trying to understand. This suggests something remarkable. The giant squid may not rely on a single hunting strategy. It may be more flexible, more adaptable than we ever imagined. Some researchers now believe that the giant squid's behavior changes depending on conditions. In areas where prey is more abundant, it may become more active. In deeper, more barren regions, it may revert to stillness. A dynamic predator, shifting between strategies as needed. But observing these behaviors directly is incredibly difficult. The deep sea remains one of the least explored environments on Earth. And the giant squid remains one of its most elusive inhabitants. Every new glimpse, every fragment of data, reshapes our understanding. And yet, the picture is still incomplete. Because there is something else about the giant squid that continues to puzzle scientists. Something that doesn't quite fit. Its nervous system. Compared to many fast predators, the giant squid's neural processing appears unusual. Not slow, but different. Optimized not for rapid pursuit, but for timing, precision, decision-making in a world where milliseconds matter. This raises an unsettling possibility. What if the giant squid is not just reacting to its environment, but predicting it? What if, in the darkness, it is not simply waiting for prey to come within reach, but positioning itself in ways we don't yet understand? Because in a place where visibility is nearly zero and encounters are rare, survival may depend on anticipating the future. And this is where the mystery deepens. Despite decades of research, we still do not fully understand how the giant squid navigates its world, how it chooses where to drift, how it decides when to strike, or how it avoids becoming prey itself. we have begun to unravel the myth. We have moved beyond the idea of a mindless monster lurking in the deep. But in doing so, we have uncovered something far more intriguing. A creature that exists on the edge of our understanding, balancing stillness and action, perception and prediction, predator and prey, and perhaps most unsettling of all, a creature that sees the darkness not as emptiness, but as information. In the next part, we descend deeper into the biology, intelligence, and evolutionary past of the giant squid, to uncover how this enigmatic hunter came to rule a world without light, and why, even now, it continues to challenge everything we think we know about life in the deep sea. Long before humans ever imagined monsters beneath the waves, long before ships crossed oceans or myths took shape in the minds of sailors, the ancestors of the giant squid were already here. Silent, soft-bodied, perfecting a way of life in darkness that would endure for millions of years. To understand the giant squid, we must go back. Not thousands of years, but hundreds of millions. In the ancient oceans of the Paleozoic era, long before dinosaurs walked the earth, early cephalopods drifted through shallow seas. Creatures like orthocones, relatives of modern squid and octopuses, carried long, chambered shells and moved using primitive jet propulsion. They were among the first intelligent hunters in the ocean. But they were also vulnerable. Over time, evolution began to strip away their protection. Shells became internal, then reduced, then vanished entirely. At first glance, this seems like a disadvantage. Why would a creature abandon armor in a world full of predators? The answer lies in flexibility. Control. Without a heavy external shell, early squid ancestors became more agile, more responsive, more capable of navigating complex, three-dimensional environments. And as some species moved into deeper waters, these traits became essential, because the deep sea is not just dark. It is unpredictable. Food is scarce. Encounters are rare. And survival depends on efficiency above all else. In this environment, the lineage that would become the giant squid took a different path. Instead of becoming faster, it became smarter about energy. Instead of chasing, it learned to wait. Its body evolved to minimize effort. Soft tissues, reduced skeletal structure, a buoyant form that could hover with minimal movement. But while its body became more passive, its sensory systems became more advanced. The giant squid's brain, though not as large as that of mammals, is highly developed for a cephalopod. Its neural architecture is complex, distributed, capable of processing vast amounts of sensory information. Unlike vertebrates, much of its intelligence is decentralized. Its arms contain their own neural networks, capable of responding, adjusting, even deciding independently of the central brain. This means that when the giant squid strikes, it is not just a single action. It is a coordinated event, multiple systems acting simultaneously, tentacles extending, hooks rotating, suckers gripping, all in perfect synchronization. And this coordination must happen in near total darkness. Which brings us back to its eyes. The giant squid's enormous eyes are not just large for the sake of size. They represent a precise evolutionary solution to a specific problem, detecting faint, diffuse light across vast distances. In the deep sea, light does not travel far. But large eyes can capture more photons, more particles of light, than smaller ones. This increases sensitivity, allows detection of even the weakest glimmers. But there is a limit. Beyond a certain size, increasing the eye further yields diminishing returns. The energy cost becomes too high. And yet, the giant squid pushes right up against that limit, almost as if evolution was willing to pay any price to see just a little more. Because in its world, that small advantage could mean the difference between life and death. When a sperm whale descends into the deep, it disrupts everything. Its massive body displaces water. Its movement triggers waves of bioluminescent flashes. Tiny organisms light up in response, creating a glowing outline of the predator. To most creatures, this happens too quickly, too faintly to detect. But to the giant squid, it may be visible, a distant shimmer, a ripple of light, a warning, and in that moment, the squid must decide. Stay still and risk detection, or move and reveal its position. This is not just hunting. This is survival at its most delicate balance. But despite these adaptations, encounters between giant squids and sperm whales do occur. And when they do, they leave evidence. Scars. On the skin of sperm whales, researchers have found circular marks, patterns that match the suckers of giant squid. Some of these scars are deep, indicative of powerful struggles. This tells us something important. The giant squid does not always remain passive. When threatened, it can fight. Its tentacles are not just for capturing prey. They are weapons, capable of gripping, tearing, resisting. And yet, even with these defenses, the sperm whale remains the dominant force. This predator-prey relationship has likely shaped the evolution of both species for millions of years. A silent arms race in the depths. One evolving better detection, the other refining its hunting techniques. But the giant squid is not alone in its world. It shares the deep sea with a host of other extraordinary creatures. Bioluminescent fish, transparent jellyfish, other cephalopods, some even more mysterious. Among them is the colossal squid, a distant relative, larger and even less understood. While the giant squid relies on elongated tentacles for ambush, the colossal